Hi friends. Welcome to Content Factory. Today I am talking about snow and winter season. Winter is the coldest season of the year in polar and temperate climates. It occurs after autumn and before spring. The tilt of Earth's axis causes seasons. Winter occurs when a hemisphere is oriented away from the sun. Different cultures define different dates as the start of winter, and some use a definition based on weather. When it is winter in the Northern Hemisphere, it is summer in the Southern Hemisphere, and vice versa. In many regions, winter brings snow and freezing temperatures. The moment of winter solstice is when the sun's elevation with respect to the North or South Pole is at its most negative value, that is, the sun is at its farthest below the horizon as measured from the pole. The day on which this occurs has the shortest day and the longest night, with day length increasing and night length decreasing as the season progresses after the solstice. During winter in either hemisphere, the lower altitude of the sun causes the sunlight to hit the Earth at an oblique angle. Thus a lower amount of solar radiation strikes the Earth per unit of surface area. Furthermore, the light must travel a longer distance through the atmosphere, allowing the atmosphere to dissipate more heat. Compared with these effects, the effect of the changes in the distance of the Earth from the sun is negligible. Snow comprises individual ice crystals that grow while suspended in the atmosphere, usually within clouds, and then fall, accumulating on the ground where they undergo further changes. It consists of frozen crystalline water throughout its life cycle, starting when, under suitable conditions, the ice crystals form in the atmosphere, increase to millimeter size, precipitate and accumulate on surfaces, then metamorphose in place, and ultimately melt, slide or sublimate away. Snowstorms organize and develop by feeding on sources of atmospheric moisture and cold air. Snowflakes nucleate around particles in the atmosphere by attracting supercooled water droplets, which freeze in hexagonal-shaped crystals. Snowflakes take on a variety of shapes. Basic among these are platelets, needles, columns and rime. As snow accumulates into a snowpack, it may blow into drifts. Over time, accumulated snow metamorphoses by sintering, sublimation and freeze-thaw. Where the climate is cold enough for year-to-year accumulation, a glacier may form. Otherwise, snow typically melts seasonally, causing runoff into streams and rivers and recharging groundwater. Major snow-prone areas include the polar regions, the northernmost half of the Northern Hemisphere and mountainous regions worldwide with sufficient moisture and cold temperatures. In the Southern Hemisphere, snow is confined primarily to mountainous areas, apart from Antarctica. Snow affects such human activities as transportation, creating the need for keeping roadways, wings, and windows clear, agriculture, providing water to crops and safeguarding livestock, sports such as skiing, snowboarding, and snow machine travel, and warfare. Snow affects ecosystems, as well, by providing an insulating layer during winter under which plants and animals are able to survive the cold. Snow develops in clouds that themselves are part of a larger weather system. The physics of snow crystal development in clouds results from a complex set of variables that include moisture content and temperatures. The resulting shapes of the falling and fallen crystals can be classified into a number of basic shapes and combinations thereof. Occasionally, some plate-like, dendritic and stellar-shaped snowflakes can form under clear sky with a very cold temperature inversion present. Snow clouds usually occur in the context of larger weather systems, the most important of which is the low-pressure area, which typically incorporate warm and cold fronts as part of their circulation. Two additional and locally productive sources of snow are lake effect storms and elevation effects, especially in mountains. Snow affects human activity in four major areas: transportation, agriculture, structures, and sports. Most transportation modes are impeded by snow on the travel surface. Agriculture often relies on snow as a source of seasonal moisture. Structures may fail under snow loads. humans find a wide variety of recreational activities in snowy landscapes. Snow affects the rights of way of highways, airfields, and railroads. They share a common tool for clearing snow, the snowplow. However, the application is different in each case. Whereas roadways employ anti-icing chemicals to prevent bonding of ice, airfields may not. Railroads rely on abrasives to enhance traction on tracks. Snow crystals form when tiny supercooled cloud droplets freeze. These droplets are able to remain liquid at temperatures lower than -18 degrees Celsius. Because to freeze, a few molecules in the droplet need to get together by chance to form an arrangement similar to that in an ice lattice. The droplet freezes around this nucleus. In warmer clouds, an aerosol particle or ice nucleus must be present in the droplet to act as a nucleus. Ice nuclei are very rare compared to cloud condensation nuclei on which liquid droplets form. Clays, desert dust, and biological particles can be nuclei. Artificial nuclei include particles of silver iodide and dry ice. And these are used to stimulate precipitation in cloud seeding. The coldest average temperatures of the season are typically experienced in January or February in the Northern Hemisphere and in June, July, or August in the Southern Hemisphere. Night time predominates in the winter season, and in some regions winter has the highest rate of precipitation as well as prolonged dampness because of permanent snow cover or high precipitation rates, coupled with low temperatures, precluding evaporation. Blizzards often develop and cause many transportation delays. Diamond dust, also known as ice needles or ice crystals, forms at temperatures approaching -40 degrees Celsius due to air with slightly higher moisture from above mixing with colder, surface-based air. They are made of simple hexagonal ice crystals. Over the course of time, a snowpack may settle under its own weight until its density is approximately 30% of water. Increases in density above this initial compression occur primarily by melting and refreezing, caused by temperatures above freezing or by direct solar radiation. In colder climates, snow lies on the ground all winter. By late spring, snow densities typically reach a maximum of 50% of water. Snow that persists into summer evolves into neve, granular snow, which has been partially melted, refrozen and compacted. Neve has a minimum density of 500 kilograms per cubic meter, which is roughly half of the density of liquid water. It also has a more extensive classification of deposited snow than those that pertain to airborne snow. The categories include both natural and man-made snow types, descriptions of snow crystals as they metamorphose and melt, the development of hoarfrost in the snowpack and the formation of ice therein. Each such layer of a snowpack differs from the adjacent layers by one or more characteristics that describe its microstructure or density, which together define the snow type and other physical properties. Thus, at any one time, the type and state of the snow forming a layer have to be defined, because its physical and mechanical properties depend on them. Physical properties include microstructure, grain size and shape, snow density, liquid water content, and temperature. Scientists study snow at a wide variety of scales that include the physics of chemical bonds and clouds, the distribution, accumulation, metamorphosis, and ablation of snowpacks, and the contribution of snowmelt to river hydraulics and ground hydrology. In doing so, they employ a variety of instruments to observe and measure the phenomena studied. Their findings contribute to knowledge applied by engineers, who adapt vehicles and structures to snow, by agronomists, who address the availability of snowmelt to agriculture, and those who design equipment for sporting activities on snow. Scientists develop and others employ snow classification systems that describe its physical properties at scales ranging from the individual crystal to the aggregated snowpack. A subspecialty is avalanches, which are of concern to engineers and outdoors sportspeople. Snow science addresses how snow forms, its distribution, and processes affecting how snowpacks change over time. Scientists improve storm forecasting, study global snow cover and its effect on climate, glaciers, and water supplies around the world. The study includes physical properties of the material as it changes, bulk properties of in-place snow packs, and the aggregate properties of regions with snow cover. In doing so, they employ on-the-ground physical measurement techniques to establish ground truth and remote sensing techniques to develop understanding of snow-related processes over. Subscribe this channel to get more informative videos.